Welcome to another episode of our video series of the mechanics of human cognition. It's great to be back. I was thinking this morning, after a particularly good night's sleep, just how foundational it is. It's something we all do, but very few of us really get its power. Absolutely. We tend to treat it like this necessary evil, something to get out of the way. But as we're about to explore, that way of thinking could not be more wrong. It's a fascinating disconnect between our culture and our own biology.
And that disconnect is really the whole issue, isn't it? Our modern culture, it glorifies the grind. We're basically told to sacrifice sleep for productivity, framing it as this enemy we have to conquer. But the biological reality, it tells a completely different story. Sleep isn't your enemy. It's the very foundation that high-level thinking and physical performance are built on. So to declare war on sleep is quite literally to declare war on yourself.
Exactly. This whole mindset frames sleep as a sign of laziness or maybe a lack of ambition. So we try to hack it, right? We shorten it, we conquer it, all so we can get more done. But what are we really doing? We're directly sabotaging the brain's most essential, non-negotiable maintenance schedule.
Okay, so to really understand this, we have to start by completely dismantling the single biggest myth out there, that sleep is a passive state. It is the exact opposite. While you're asleep, your brain is performing this whole suite of complex, energy-intensive tasks that it simply cannot do while you're conscious.
This slide really shows the critical distinction. Think about it. Your body can get physical rest just by lying on the couch. Your muscles relax, your heart rate slows down, but your brain, that's a different story. Exactly. Your brain cannot perform its deep cleaning and memory sorting functions without entering the very specific and very active neurochemical state we call sleep. Passive rest for the body is not at all the same as active maintenance for the brain.
And evolution provides this absolutely stunning example of just how non-negotiable this need is. Dolphins are mammals. They have to come up for air. So full sleep, like we experience it, would be a death sentence for them. So evolution came up with this incredible solution, unihemispheric sleep. One half of the dolphin's brain goes to sleep while the other half stays alert, managing breathing and just watching out for predators. The very fact that such a complex adaptation exists proves that sleep isn't some optional luxury. It's a critical biological imperative that nature will go to extraordinary lengths to preserve.
So, the crucial point is this: we have to reframe sleep. It's not about powering down, it's about taking our most valuable asset, our brain, into the shop for its essential nightly tune-up. It's a period of intense, vital work.
So what does this maintenance actually look like? Well, it's this meticulously choreographed journey, a cycle that our brain takes multiple times every single night.
We move through these stages over a roughly 90-minute cycle. We kind of descend into the deepest stages of what's called NREM sleep, then we ascend back up and cap the whole cycle off with a period of REM sleep. Then we do it all over again, 4 or 5 times a night. And it's probably worth clarifying those terms. NREM is non-rapid eye movement sleep. That's characterized by those deeper, restorative stages. And REM, or rapid eye movement sleep, is a more neurologically active state. It's where most of our vivid, story-like dreaming happens. Each stage serves a distinct, critical function. So when we're awake, our brain's neuronal firing is pretty chaotic. It's like a crowd with thousands of different conversations happening at once. But in deep non-REM sleep, something remarkable happens. The neurons begin to fire in unison. They create these slow, powerful, synchronized brainwaves. It's like that chaotic crowd suddenly becomes a choir, with everyone singing the exact same note. And this coherence is what allows for that profound restoration and the transfer of memories from short-term to long-term storage.
And one of the most incredible discoveries in neuroscience in the last decade happens during this deep sleep state, the activation of the glymphatic system. This is essentially the brain's dedicated cleaning service. You can really think of it as a high-pressure power wash for your neural circuitry that only runs at night.
And this system is 10 times more active while we sleep. During this time, cerebrospinal fluid is pumped through the brain tissue, literally flushing out all the metabolic waste products that build up during the day. And critically, one of these waste products is beta-amyloid protein, which is the plaque-forming protein that's strongly associated with Alzheimer's disease. So this nightly cleanup isn't just about feeling refreshed. It is an active primary defense against long-term neurodegeneration.
Beyond just cleaning, the sleeping brain acts like a master curator of information. It replays the neural patterns from the day, and it sifts through all your experiences to decide what's worth keeping. And the primary tag for what's important is emotion. Experiences with a strong emotional charge get flagged for consolidation into long-term memory. Meanwhile, all the trivial, emotionally neutral information gets discarded. This is precisely why sleep is completely non-negotiable for effective learning and memory.
So if that's all the incredible work happening every single night,
What's the cost when we skip it? Well, the biological price of sleep debt is steep, and it goes far, far beyond simply feeling tired.
In metabolic terms, our bodies are in this constant push and pull between anabolism, which is building and repairing, and catabolism, which is breaking things down. When we're young, anabolism dominates. As we age, the balance naturally shifts more towards catabolism, towards breakdown. But sleep deprivation acts as a massive accelerant. It dramatically pushes the body into a catabolic state, effectively speeding up the negative biological aspects of the aging process.
And here's a staggering piece of data on that. Growth hormone, which is critical for tissue repair and metabolic health, is released primarily during the first bout of deep sleep. A single night of insufficient sleep can slash the secretion of this vital hormone by over 70%. That has an immediate, measurable impact on your body's ability to heal and maintain itself.
The evidence is overwhelming. Fighting sleep is a losing battle. The intelligent approach is to work with our biology, and that begins with understanding and respecting our internal clock.
Every system in our body is governed by a roughly 24-hour internal cycle called the circadian rhythm. This rhythm dictates predictable peaks and troughs in our hormones, our alertness, and our physical performance throughout the day. For instance, the hormone cortisol naturally peaks in the early morning to promote wakefulness, giving us that initial drive to start the day. Then in the evening, the brain's pineal gland begins to secrete melatonin, the hormone that signals to the entire body that it's time to prepare for sleep. So, what is the primary external cue that calibrates this master clock? It's light. Our entire biology evolved in a world of bright days and truly dark nights. Light hitting the photoreceptors in our eyes is the most powerful signal to the brain that it's daytime. This is exactly why exposure to light at night, particularly the blue spectrum light from our screens, is so disruptive. It sends a profoundly confusing signal to the brain, slamming the brakes on melatonin production and tricking our internal clock into thinking it's still midday. But we can use this mechanism to our advantage. If light is the master switch, we can consciously use it to set our clock correctly. And the most effective way to do this is with morning light exposure. Getting just 15 minutes of bright, natural light soon after waking sends a powerful signal that anchors your entire 24-hour cycle. It effectively starts the countdown timer for melatonin release that evening, making it far easier to fall asleep at the right time.
So it's time to completely reframe our relationship with sleep. It is not a moral failing or a sign of weakness. It is the single most effective thing you can do each day to reset, repair, and potentiate your brain and body.
Let's just summarize the big takeaways. Sleep is not passive rest, it's active brain maintenance. It's the process by which we consolidate memory and enable learning. It is a critical regulator of our entire endocrine system. It's a primary defense against neurodegenerative disease. And ultimately, it is the foundation upon which all our waking performance is built.
The goal, then, should not be to conquer sleep, but to partner with it, to understand its mechanics and align our behavior with our biology. So we'll leave you with this question. Based on the mechanics we've talked about, what is the one simple change you can implement starting tonight to begin harnessing your brain's hidden superpower?